Okay, so this video is going into a few more advanced concepts to do with heat and temperature. Heat is one of the most important types of energy, and in particular, we're going to talk about the fact that heat and temperature are not the same. The fact that people often mistake, and it's a common misconception. Heat and temperature are not the same at all, although they are related to each other. So we've already learned that heat is a type of energy, and in particular it's energy that transfers from hotter to colder objects. So energy transferred from hot to cold. And temperature is the way that we measure the amount of heat in a material. So it's a measure of the amount of heat in a material. But the problem that scientists have discovered is that it's actually impossible to measure heat in a material, because heat only really exists when it transfers from a hot object to a cold object. If we have something hot, like a beaker of hot water, we can't really measure how much heat is in there. But what we can measure is how much kinetic energy the particles have that make up the water. So it's impossible to measure heat in a material. So instead, we measure the kinetic energy, or how quickly the particles are moving. Instead, we measure kinetic energy of particles. And that's what the temperature is measuring when we use a thermometer. Because we know that in a hot material, like hot water, the particles have a lot of kinetic energy and they're flying around really fast. Whereas in a cold material, like this cold water in a beaker, the particles are moving quite slowly, so they have a low kinetic energy. Low kinetic energy. The next thing we'll look at is a few different ways that or a few different units that we can measure temperature in. And these are the temperature scales. So a scale is just a number line. And in each one of these scales, there's a minimum temperature, that's the lowest possible temperature. So let's look at the first temperature here, and it's the most common one we use in Australia, which is degrees Celsius. It's the one we all know whenever we look at the weather forecast, or if we're measuring the temperature of something, it's always in degrees Celsius. And the way that degrees works is it's based around 0 degrees Celsius is when water freezes. And that's what scientists decided when they created the degrees Celsius scale. And then they also said, let's look at when water boils, and we'll call that 100 degrees Celsius. So anything hotter than when water boils must be greater than 100 degrees Celsius, and anything colder than 0 degrees must be lower than when water is freezing. And in theory, the lowest possible temperature in degrees Celsius is negative 273. And this is called absolute zero. You might have heard of it before. It's actually only a theory that scientists predict because it's actually impossible to get that cold. Remember, thinking back to particles moving, as the temperature gets lower and lower and lower, particles have less and less kinetic energy, so eventually, if they're cold enough, the particles will stop moving completely. But we know that particles can never stop moving, so there is actually no possible way to get as low as negative 273. But we know that that's as low as we can go in our degrees Celsius. There's another common measurement that's used in America in particular that's called degrees Fahrenheit. And they used to use it in Europe and Australia too. Fahrenheit, it actually has smaller units than degrees Celsius. So for every degree Celsius, we go up by not quite a degree Fahrenheit. And if we start comparing them, we can see that 0 degrees Fahrenheit is actually lower than 0 degrees Celsius, and 32 degrees Fahrenheit is equal to 0. But when we get all the way up to 100 degrees Celsius, we've got up to 212 degrees on the Fahrenheit scale. So a single degree Fahrenheit is a lot smaller. The units are smaller. And just like on the degrees Celsius, there's a minimum possible temperature, which is 459 degrees Fahrenheit. And that's absolute zero in Fahrenheit. Another temperature scale, which you probably haven't heard of, is called kelvins. And the unit is called capital K, or is capital K. And kelvins are what we use in science most of the time. And the good thing is that 1 Kelvin unit is the same as 1 degree Celsius. So we have the same size units. But all they do with kelvins is they move 0 Kelvin all the way down to the bottom of the scale. So 0 Kelvin is the same as negative 273 degrees. So by the time we get up to 0 degrees Celsius, we're at 273 Kelvin. And we don't use a degree symbol for kelvins, just the capital K. And so again, if we go up by another 100 degrees to 100 degrees Celsius, then we must be at 373 Kelvin. And measuring in Kelvin just makes things easier because we're starting with 0 at the very bottom and we never have negative units. So it makes doing calculations in science a little bit easier.